resistor 10 ohm and this resistor 6 ohm and this resistor 7 ohm and again this is 5 ohm. Okay, so this is the given circuit, right? For this circuit, we need to find out node voltages, right? So let's first we will solve this problem and also by discussing the steps to be followed to solve the node. Okay, so let's start with first step number 1. So say this step is similar to the top the steps we followed in mesh analysis. Okay, so better you always try to compare this with the mesh so that you will understand better how to deal mesh problem and how to deal nodal problem. So you know that in mesh problem, we always first try to count the number of meshes where we need to find out the current. Okay, right? And similarly, in nodal method, you need to find out the number of nodes, right? I'll repeat, you need to count the number of nodes at which the voltage is unknown. So that is step number 1. Okay, all right. Find the number of nodes at which the voltage is unknown. This is the first step. Okay, right? So let us try to figure out for the particular circuit how many nodes are there. You just forget about whether the voltage is known or whether voltage is unknown. You first try to find out for the given circuit how many nodes are there. First, tell me in this circuit how many nodes are there. Anyone? How many nodes are there?
Yes, sir.
5. Kamalesh told 5. Any other answers?
6, sir.
3. Okay. Actually, answer. Someone said 6.
Yes, sir.
I think
6.
4, sir.
Actually, the answer is yes. Kamalesh, your answer is correct. Answer is 5. Let's see how the answer is 5. We can actually claim this as a node, right? Because it is connecting 6-volt battery and 5 ohm resistor. Okay, so I'll take this as a node and I put this node as A. Let's say example this node as A. Then obviously this point also node because it is connecting 3 elements. You know, basic definition for node, the point at which 2 or more than 2 elements are connected together. That we are referring as a node, right? Here it is connecting 3 elements. So I can take this also node. So here this is actually B, right? Then this point also node because again it is connecting 3 elements. So I can put this as node C. Then finally we are having one more point. This also connecting 2 elements, 10 volt and 5 ohm. So this can also be preferred as a node. So I'll name this as a G, right? And in addition to that, you see down. So down actually, see all actually connected to one common point, right? The same circuit I think you've seen in one class when you discuss the concept of node. Okay, same type of circuit. See that here you can't climb this to this to as a node because in between there is no elements. It is just a wire, normal wire, right? That means here all are actually connected to the one common point. All these 6-volt, 10 ohm, 7 ohm, and 10 volt are connected to the single point. So what I do, I consider all this into a single point. So I'll put this as one node. I'll take that as a node G. Okay, in this node, there are 4 elements are connected to it. 6 volt, 10 ohm, 7 ohm, and 10. So actually the number of nodes for this particular circuit is 5. Okay, node A, node B, node C, node D, and node G. Clear, huh? Clear, huh? This is clear?
Yes, sir.
Okay, done. So now, but what I told, we need to find out node at which the voltage is unknown. So totally there are 5 nodes, node A, node B, node C, D, E, all are actually nodes. Okay, right? Now if you see among these 5 nodes, actually node A voltage is known, right? Because node A actually connected to the 6-volt battery. So it is a +6, right? +6 terminal is connected directly to the node A, which means that the voltage at node A is 6 volt. So I can take the voltage as node A as 6 volt. Right? Similarly, the voltage across at node D, see it is also connected to the 10-volt battery, again plus 10 volt. Plus 10 volt directly connected to the node D, which means that the voltage at node D also known, which is equal to 10 volt. Right? It is directly connected 10 volt. Okay. Now among this 5 node, actually the node B, node C, and node E, nodes for which the voltage is unknown. Okay, the voltage at which the node at which the voltage is unknown. Okay, only 3 unknown nodes are there for this particular circuit. Right? So I'm repeating again, mesh analysis, you can easily get the number of meshes, but for nodal, you need to be very careful while choosing the unknown nodes. Sometimes they directly specify, sometimes they won't specify. You need to find perfectly the unknown voltages, the unknown nodes where which voltage to be found. Okay, so now there are 3 unknown nodes, right? B, C, and E. And one more point here, among these 3 unknown nodes, you must choose one node as a reference node. Okay, choose one node as reference. Okay, choose one node as a reference. See, reference means it is a ground node, and you see that in your house also. If you see your house, entire electrical apparatus are grounded, right, or earthed to the ground terminal. The purpose is to protect all the electrical apparatus and also protect the humans from the electrical shocking, right? So, for safety purpose, all the electrical circuit must be grounded, right? And the general symbol we use to represent the ground terminal will be like this. Okay, this is the symbol for ground terminal. Okay, right? This is the ground terminal symbol. Please note down this. And always the ground voltage is 0 volt. Okay, always the ground voltage is 0 volt. The potential at ground is 0. Right? Okay, so what I'm saying is here, first you need to find out the node at which the voltage is unknown. And among that, you choose any one node as a reference. Again, it is arbitrary choice. It is your choice. There is no rule to choose only this as a reference or that as reference. It is up to you. You can choose any node as a reference. But in general, we choose the node at which the number of elements are connected together as a reference. The large number of elements are connected together as a reference. Okay, it is just a thumb rule only. It is not a condition or it is not a mandatory. Okay, you can choose any one node as a reference node, but in general, we choose the node at which a lot of elements are connected. Now, for this case, let us see here we have 3 unknown nodes B, C, E, and in that actually EC connecting lot of elements, right? It is connecting 4 elements: 6 volt, 10 ohm, and 7 ohm, and 10 volt. So I'll go with E as a reference. Okay, so better you always follow this way. Always you choose down node. Okay, down node as a reference for easy purpose. Just take always the down node as a reference. So we the same way I'll choose now node E as a reference. Okay, node E as a reference. Right, and as I told, now if it is reference, then obviously the node E voltage is 0 volt. We need to take the node E voltage is 0 volt. Now we have only 2 unknown nodes, that is node B and node C. For that, we need to find out the voltages by applying the nodal method. Okay, let's see how we can do. Right. Next, first, this is the first step. Okay, so first step, you carefully identify the node at which the voltage to be found. Right, and you try to figure out what are all the unknown nodes. In that, you choose anyone as a reference. That means if you're having 3 unknown nodes, you choose one reference, and the remaining only 2 nodes will be there. For that 2 node, we are going to apply the Kirchhoff current law to form the case equations. Okay, right. So next step 2. So step 2, actually in mesh analysis, in step 2, what we do, we just mark the direction of current in clockwise, right? And also we label the currents. Same way here in nodal method, whatever the node at which you are going to find out the voltage, for that you just label it like VA, VB, VC, or V1, V2, V3. Okay. So for that, I will draw the 1 second circuit. Right. This is 6 volt. This is 10 volt. This is 5 ohm, 6 ohm, again 5 ohm, 10 ohm, 7 ohm. Okay, and I'll choose, this is the node at which we are going to find out voltage now. So I'll choose this node as node number 1 and this node as node number 2. Okay, node 1, node 2. And let us consider the voltage at node 1 as V1 and voltage as node 2 as V2. Right, that means node 1 voltages, let us assume V1, right, and node 2 voltages, node 2 voltage you assume as V2. You can take VA, VB, no problem. It is your, you can name anything, like, but you just keep V, then you can take VX, VY, or VA, VB, or V1, V2. And this is step 2. Then step 3 is important step. Here we are going to apply KCL to form the equations. It is similar to that of in mesh, right? In mesh we apply KVL, right? KVL to form the mesh equation. Here we are going to apply KCL to form the mesh. That is nodal equation. So let us apply KCL at node 1. So for that, first you just recall the KCL statement. What is KCL? Vaisali, tell me what is KCL? Define KCL. Vaisali, tell me define KCL, Kirchhoff current law. Vaisali, respond. Hello, are you available? Hey, my voice is audible.
Yes, sir.
Vaisali, respond. Yeah, I'm asking you only. Define Kirchhoff current law. Hello. Vaisali, I'm calling for last time. If you are not responded, I will remove you from the class. Someone define Kirchhoff current law.
Deals with current and potential difference.
Yes. See, as per Kirchhoff current law, a junction or node, the sum of incoming current equal to sum of outgoing current, right? Or else we can say that the algebraic sum of current, yeah,
Zero.
yeah, algebraic sum of current meeting at the junction is equal to 0, right? So that means that, which means that first we need to find out current through the elements which are connected to the node number 1, right? So just look at the node number 1. See, node number 1 actually having 3 components, right? 5 ohm, 6 ohm, and 10 ohm. So we need to find out current to this 3 components, 5 ohm and 6 ohm and 10 ohm. Then either you algebraically sum and then equate to 0, or else based on the direction of current, you take incoming current equal to outgoing current. This is the general approach. Okay. But what approach here we are going to attack? First of all, you just assume all the currents. Okay, you just assume all the currents from node number one are outgoing current. And again, it is a assumption only. Just to avoid confusion, you always choose. Okay, you always choose the current which is coming, which is from node number one. All are outgoing currents. Okay, see, it is just again I'm repeating just assumption. If you refer some other book, they may follow different approaches, but we'll keep it this way. Always assume a particular node, the current is outgoing current. It is similar to that of we always assume current in clockwise, right? In mesh analysis. The same way here in node, you assume all the currents are outgoing current. Okay, sometimes in the problem, if they mention the direction of current, you keep as it is. Don't change it. Right? I'll repeat. In the problem itself, if they mention the direction of current towards the node or away from the node, you keep as it is. Otherwise, you always choose the current from that particular node is away current, right? So just maybe take this as a note. We'll apply the same thing here. So for that, what I do, I just take the node number one. So I'll take node number one. I'll put 3 resistors which are connected to the node number one. 5 ohm, 6 ohm, and 10 ohm. And if you see that this 5 ohm is actually connected at A, right? Which is connected to the point A. And this is connected to point 2, that is node 2. And this point is node 1. And this point is actually connected to E, node E. Right? I just drawn the node 1 common node again here. Okay, now we'll try to assume all the currents are outgoing currents here. So let us take the current through 10 ohm, which is away from the node 1, which is equal to I1. Okay, and let us choose current to 5 ohm as I2, and also which is away from the node 1. Then similarly, the current through 6 ohm, let us assume I3, and which is again away from the node 1. Okay, so I repeat, assume all the currents are away from the node. I have assumed the current to 10 ohm as I1, current to 5 ohm as I2, and current to 6 ohm as I3. Right? So now we can easily apply the Kirchhoff current law. Right? You know, as per Kirchhoff current law, at node or junction, the algebraic sum of current equal to 0. Otherwise, incoming current equal to outgoing current. The sum of incoming current equal to sum of outgoing current. Okay. Now, if you see here all the currents are outgoing currents, right? So we assume all the currents are outgoing current. So I'll simply add all this the current, and then you get 0, you'll get the case equation. So that means now I1 plus I2 plus I3. So these are all outgoing currents, and there is no incoming current, so I'll put that as a 0. Right? Okay. Now here if you see, actually I is, as per Ohm's law, V by R, right? I is nothing but V by R. Okay. Right? And more specifically here, voltage is nothing but, voltage is nothing but it is a potential difference between the 2 points, which means that, for example, you're having a resistor like this, and the first resistor is connected at point number 1, and second resistor is connected at point number 2. If you want to know what is the voltage between these two terminals, we need to consider the voltage at this point and voltage at this point, and now the common voltage is V1 minus V2. Okay, this is the general definition for voltage, right? Voltage is actually nothing but the potential difference between the 2 points. So in this case, now voltage across this resistor is voltage at this point and voltage at this point minus voltage at this point, right? This is what the voltage actually. Okay, so for that means if you want to find out voltage across resistor, you just see where the particular resistor, okay, between which of the 2 nodes the resistor is connected, and you just take the node voltages, subtract the 2 node voltages to get the voltage. Okay, so I'll apply this formula here, and let us try to find out I1, I2, I3. So again, listen carefully, this is an important step. So let us try to figure out first I1. So here tell me what is I1. Actually I1 is current to 10 ohm, right? So the 10 ohm actually connected between node 1 to node E, right? Node 1 voltage unknown, right? We don't know node 1 voltage, which we already assumed as V1. So I'll put V1 as it is, minus, see, it is a potential difference. Voltage is potential difference between node 1 to node E, right? V1 minus voltage at E, we already assume voltage at P as 0 volt. It is because it is a ground, right? So it is going to be V1 minus 0 divided by its resistance divided by the resistance 10 ohm plus 10. V1 minus 0 divided by plus 10. This is actually I1 current. Then let us try to get I2 current. See, I2 is actually current through 5 ohm resistor. This 5 ohm resistor. Actually, this 5 ohm is connected between node 1 to node A. Okay, node 1 to node A. Right, and that means now the voltage across 5 ohm V1 minus the voltage at node A. What is voltage at node A? What is voltage at node A?
6 volts.
Yes, 6 volt, right? It is directly given in the problem, right? This node voltage is 6 volt actually, because directly plus 6 is connected to the node A. So I can keep that as here. Okay, V1 minus 6 divided by resistance 5, right? Then plus I3. Plus I3. Now tell me what is I3 current? I3 is actually the current through 6 ohm resistor, which is connected between node 1 to node 2. Okay, which is connected between node 1 to node 2. Right? So node 1 voltage actually V1 and node 2 voltage actually V2 minus V2. Right? And the resistance 6 divided by 6, which is equal to 0. Right? Which is equal to 0. Okay, now we just simplify this expression. Before that, any doubt in this? This is clear? Any doubt in this?
Okay.
Okay, done. So now what I do, I write each term separately. V1 by 10, then minus 0 by 10, it is 0 only, so I'm not going to consider that. Then we move on to the second term, V1 by 5, right? V1 by 5, then minus 6 by 5, plus V1 by 5, then minus 6 by 5. So I'm just separating each and every element in numerator, denominator, and plus V1 by 6 minus V2 by 6, okay, which is equal to 0. Now you just simplify this expression and write the equation in terms of V1, V2 and equal to constant term. So first you try to get V1 coefficient. So V1, there are 3 V1, right? 1 by 10 plus 1 by 5 plus 1 by 6. Right? Do it and find what is 1 by 10 plus 1 by 5 plus 1 by 6. Find first V1 term. Tell me now. 1 by 10 plus 1 by 5 plus 1 by 6. Arun Kumar, tell me. Arun Kumar. Arun Kumar. Arun Kumar. Okay, you find out V1 term and tell me.
0.7
by 15. Okay, let's check. You tell me in terms of fractional number. No, 7 by 15. 7 by 15. Yes, correct. Good. See, 1 by 10 plus 1 by 5 plus
1 by 6.
1 by 6. So you get actually 0.466 V1.
4 6, sir.
Yeah, 466 V1. Then next V2, we have only one term, minus 1 by 6. 1 by 6, I think 0.167 will come, 166 will come. Let's check 1 by 6, yes, minus,
0.166.
yeah, good, 0.166 V2. Then constant term, we are having 6 by 5, 6 by 5 na 1.2, right? 1.2 minus 1.2, when you move that into the RHS side, you'll get plus 1 point, which is equal to plus 1 point. Okay, this is the equation number 1. Clear? So equation number 1, 0.466 V1 minus 0.166 V2 equal to 1 point. Rakesh, I think you did some modification on the equation. So one thing, please all of you, one thing keep it in mind. If you are decided you are going to solve the problem by using grammar rule, don't do any modification on the equation. Okay, please don't do any modification in the equation. If you are going to solve the problem by using grammar rule, you are decided you are going to solve the problem using grammar rule. Solve the equation by using grammar rule. You don't change anything on the equation 1 and also equation 2. Whatever equation you got, you take as it is.
So answer 0.3.
0 point V1 now. We need next we need to form, next we need to form equation 2. Apply KCL at node 2. Apply KCL at node 2. Before that, any doubt in this equation? So you move on to the next one, Ram. Hey, any doubt?
0.3 no sir.
Which one, Ram?
0.46 minus 0.1.
Okay, that is V1 minus V2. Both voltages are unknown. How can you subtract this two? It is an equation.
Yeah, sorry.
See, it is an equation. V1, V2, we don't know. That we are going to find. Okay. Aravind, no, Aravind, check one step. Oh, check your answers. Okay, let us take the equation 2.
Sir, in equation, sir, V1 minus 6 or 6 minus V1, sir? Your mic is muted, sir.
Okay, sorry. Sorry, actually, what you asked, they should keep V1 minus 6 only, because here is the current direction you consider outwards. Okay, so you need to take V1, then this voltage. V1 minus 6. If you consider in this way, then you can take 6 minus V1. But we have considered outwards current, so we need to take first this voltage minus this voltage. Clear?
Yes, sir.
Okay, done. Right now, we'll try to apply the KCL at node 2. Here, what I did is I take a node 2 elements. Again, node 2, there are 3 elements are connected. 5 ohm, 7 ohm, and again 6 ohm. Yes. This is 6 ohm. 3 elements are connected and same approach. Okay, and this voltage we already know. Node B voltage is already 10 volt, right? It is actually 10 volt. This voltage is 10 volt, and this voltage is 0 volt. Node E voltage 0 volt, node D voltage 10 volt. And I'll assume now all the currents are outward currents again. Let us take the current through 7 ohm as I4, and this is I5, and this is I6. Okay, it is just an assumption. You can take any like I1, IX, IY, IZ, whatever. So there are 3 currents which are going out from the node number 2. Right now, I'll apply the KCL again. So as per KCL, I4 plus I5 plus I6 equal to 0, right? Now we'll try to get one by one.
Sir?
Yeah, tell me. Yeah.
Sir,
Any
we
doubt?
taken at node 1, we taken as outward, sir.
Okay.
Then at node 2, it will come inwards only, sir, from
No, no,
node
no.
1.
No. You forgot about node 1. You are now concentrate about only node 2. Node 2,
We
you
have to do
assume,
separate.
node 2, at a particular node, you take all the currents are outgoing currents.
Okay, sir.
Now we try to apply the current here. So first I4 current, just through the 7 ohm, and you see 7 ohm is connected between node 2 to 0. So node 2 voltage, unknown voltage, right? So I'll keep that as a V2 minus this is 0. Yes, Kamalesh, good, correct. Kamalesh, very good, correct. V2 minus 0 divided by the resistance 7, right? Then plus I5. I5 is actually current through 6 ohm resistor, right? See, 6 ohm connected between node 2 to node 1. Now both voltages are unknown, and see how I am taking it. See, this actually node 2 first current is outgoing current, right? So you take this voltage first, V2, then minus V1. Okay, 6 ohm is between 2 to 1. So take V2 minus V1 divided by its resistance 6, right? Then plus next I6. I6 is the current through 5 ohm resistor. So, and see that it is connected between node 2 to node D. So node 2 voltage, it is unknown, right? Then node D voltage 10 volt. So V2 minus 10 divided by the resistance 5. Okay, V2 minus 10 divided by 5, right? Which is equal to 0. Now we just simplify this expression so that we can get the equation. So now V2 by 7, 0 by 7, 0, right? So I'm not going to answer that. Then plus V2 by 6 minus V1 by 6 plus V2 by 5 minus 10 by 5. So I'm just separating the elements. That's it. Equal to 0. Equal to 0. Now we'll try to simplify this. So that only one V2 term is there. So it is divided into 1 by 6. So 1 by 6 actually minus 0.166 V1. Then V2, there are 3 V2 terms, right? 1 by 7 plus 1 by 6 plus 1 by 5. You just find this. 1 by 7, 1 by 7 plus 1 by 6 plus 1 by 5. Okay, which is equal to 0.509, right? Plus 0.509 V2. Then we are having constant term 10 by 5 is 2, right? And it is a minus 2, but when we move into the RHS side, it is actually plus 2, right? This is equation number 2. Okay, so our equation number 1, 0.466 V1 minus 0.166 V2 equal to 1.2. And second equation, 1. Minus 1.66 V1 plus 0.509 V2 equal to 2. Now you can easily solve this two expression to find out V1 and V2. Okay. Right, let's see. You can use any method. So I'll show you again same the grammar rule approach. So now you all try the grammar rule approach and try to get the answer for this. Find the answer. So I'll write for del first. I hope you copied this side, problem side. Can I erase this one? Nodal problem side. Copy Rada this one. Hello.
Yes, sir.
Okay then.
So
Okay, thank you. Okay. Step number 4. Solve the equation 1 and 2 and find the voltage V1 and V2. Okay. So I'll apply the grammar rules again. So let us apply grammar rule. Step 4. Apply grammar rule. And find V1 and V2. Okay, so as per grammar rule, the formula for V1 as del V1 by del. Formula for V2 del V2 by del. So let us try to find out what type. So formula for del is G. Del is actually nothing but the determinant of matrix formed by the coefficient of unknown factors in equation 1 and equation 2. So equation 1 coefficients are 0.466 and then second coefficient minus 0.166. Similarly, equation 2 minus 0.166 and this is 0.509. Okay, so you just do the cross product and find the determinant. So I'll write the formula. You please do it by yourself and verify this. Anyone got the answer for del? Yes, good. Yeah, correct. Satvik, very good. So it is actually 0.21 del. Venkateswara Reddy. No, check one star. Check your answer once. Okay, next del I1. So for getting that is del V1. For getting del V1, you need to replace simply the column 1 with the constant term and remaining column you keep as it is, and you again find the determinant. Yes, Aravind, good, very good. Yes, correct. 4.4, 5.3 is correct. Good. So del V1 equal to, you just replace the first column with the 1.2 constant term, and this is minus 0.166, 0.509. Okay, find del V1. So del V1 you will get actually. See, we already did many problems. That's why I'm straight away writing the answer. Please try by yourself and try to verify this answer. Del V1 0.94. Yes, good, Sathi, correct. 0.94. Yes. Next, del V2. Replace second column. Okay, then this is okay. Replace second column with the constant term and the first column with the percentage. 0.466. Okay, right now you solve this. Find out del V2. Del V2 will get us 1.13. Okay, please verify whether you are getting this answer. Del V2. Now you can easily find out del V1 and V2. So now V1 will get 4.48. V2 will get 5.38 volt. Okay, unit need to be put proper. 4.48 volt and V2. Yes, 1.1 correct here. Yes, 1.1 or 1.13. Approximately 1.1 is correct. Del D2. Then V1 you'll get 4.48 volt and V2 as 5.38 volt.